Yes.
And now a totally different topic again. Over to Vladimir from Russia, all the way from Russia, to tell you about the JDK.
Hi. So my name is Vladimir, and I work in St. Petersburg, Russia. And basically I work on this tool, which which is not mentioned there. The name of the tool is Oracle Solaris Studio. Although Solaris word is not appropriate here because it works both on Linux and on Solaris. And it contains of lots of tools for producing native code, like compilers, which are the best in the terms of performance of the code generation, especially on Sparks, and debuggers and tools to analyze code and so forth. And main part here is that one, the IDE, which integrates all this stuff. And this IDE is an example of a product that is based on top of NetBeans as a platform. And I can just show where it is. That's how it looks like. So it's just another example of what is built on top of NetBeans. But in fact, this we also contribute to the C++ support in NetBeans. And I would say that we write more code into NetBeans than into these proprietary plugins above it. These plugins actually are needed to integrate those binary tools by Oracle. And IDE itself runs on any, since it is written on Java as NetBeans, it is able to work on any Java web platform. Okay, I'm not going to. I can talk about C++ development for an hour or two, but I won't go there. What I'm going to talk about is Java, but in a way, in a perspective of some internals, and so the code that I will display will be mostly in C or C++. First, I'd like to share a story that happened to me about a year ago, and that made me face to Java, then to C, and to Java, then back to C. As I told, I developed the IDE on top of NetBeans, so I'm a Java guy. I write Java about 90%. 90% of my code is Java. And however, our IDE, which is actually NetBeans, has a so-called remote capabilities, which allows you to run IDE on your computer and access code on another computer, whether it is Linux or Spark, and build and run and edit code there and build it and run it and so forth. And in order to provide this, and I would say in order to speed this functionality up, I had to write a small tool in C, which runs on remote platform and provides speedy access to it. And everything worked just fine until I got a bug. User complained that this remote file system does not take access control, Linux or Unix access control list into account. Now in Unix, I can give the right to access file to a particular group or user, except for these three. RWX. Then I tried to, when these files are accessed from Java, they works just fine. So there was quite a kind of perversive situation when I wanted to look how Java does it, to understand what I should read and write in this remote tool. So what I did, first I just checked it, and I wrote a very simplistic, very simple Java program, which just access files, and then I went to, as in the IDE, any name is a hyperlink. I go to java.io file, and then I saw that it is finally delegates these checks to the file system, and I went there, and then I just a moment. I opened to be able to do this. I opened a Java project with that contained the source code of Java of JDK, Java part of the JDK sources, and then I went that way. Yes, sure. And so I understood that this method is abstract, and this annotation helped me to understand where it is implemented. So I went to implementation, and then I understood that it is native. And so native method in Java is like a black box, right? But fortunately, I know that JDK sources are open, and moreover, I forget to close it. Well, if you go to the right now, what we see right now is the layout of the trunk JDK source code tree, and fortunately, it has a common subdirectory which already contains a NetBeans project for the native part of JDK and JVM. So I opened it. Oh, sorry, it's already opened. And as soon as I have all this C++ code open, I can just control-click to this native method, and I go directly to the implementation of this method in C. In C. In this case, it is in C. Sure, for me to be able to do this, there should be a project open in NetBeans that contains this code. Otherwise, RE does not know where to go, where to find this code. And so the code is quite straightforward, and it finally uses the access, which is just as you see, it's in a standard header. Oh, if you solve C or C++ code and do not know what's this, you just go to Window and IDE tools, C++ implementation. Just a moment. Yes. Here we can see, if you're not very familiar with these functions, just can see the manual pages. Okay, that's it about this story. As soon as I changed my stat or else stat function to access call, I fixed this bug. However, this is a rather simple story. Okay. What I'd like to ask you, what if I ask you a question? When? Well, everybody know what hash code is, right? Does everybody know what a system.identity hash code is? All right. All right, just a couple of lines of code. Let's see. And what if I invoke, system identity hash code on the same object, right? So, first question. Pardon? First question, you should know this method. No, do not. Okay, and then you I guess you should know this one, hash code, right? And the default implementation of the question is, if you first let us control click to this one. We went to object class, and we see that it is native, so it's kind of black box again. And the question is, what do you think? What is by default returned by the implementation of this method? Your guess. I'll tell you what I thought about it before I went to native code. But I'll try to guess.
Does it return a string?
Pardon?
String?
No, it is integer. It is a hash code of the object, and usually you override this method together with equals, and to be able to put your objects of your classes into hash tables and so forth. But by default, it has a default implementation. It could be, I don't know, incrementing something, or it could be an address of the object in the Java memory.
It goes to the heap level of the JVM, and where the object is stored, it creates some hash code addresses. From the addresses, we get some hash code. What I'm expecting.
So you mean that it is just the address of the object in the Java? There was a long time when I thought it is just an address of the object in Java address space, but obviously that would be not the very good algorithm, because first, if you allocate objects sequentially, they have sequential codes, then it is always even. I mean that divided by 4, it is 0, and so forth. Well, let us go inside. And now we see lots of macros here. Fortunately, the NetBeans C++ support allows us to just control home the macro, and we see how it is defined. And it is rather complex, but I can right-click and say navigate and view macro expansion, in which case a separate view is open, and it shows how is this macro expanded exactly in this place with these parameters. Well, there's lots of stuff here, but it's actually that's just a prologue, and probably the most. Let me press Control Escape and maximize editor. So I guess that the most interesting stuff is done here. And by the way, if we return and go by that hyperlink, we'll see that we again went just into the same place. So let's go to that object synchronizer and see what happens there. Well, sure, we can read all this code. I personally think that the code is the most valuable, most truthful source of information about what is going on. Well, human language express, whether it is English, Hindi, or Russian, express opinions, while programming language express facts. But however, we need to interpret it and understand which if branches will be passed. So I would propose to do the following. I would propose to go to my program. Well, let me comment out on this part, as we do not need this, and set a breakpoint here and run our program. Oh, no, I meant debugging through. So right now I launched Java debugger and it hit breakpoint, and we are now on this breakpoint. And now what I'm going to do is to invoke step into. Since we have both C++ and Java support, right now, apart from Java debugger, native debugger, which is GDB, was launched, and it attached the process and loaded. You noticed significant delay is for the first step into, because the GDB process is launched, then it attaches to the process, then it stops it, loads symbol tables, then it inserts temporary breakpoint in this method, and releases the process. And now we are in native debugger, and we can, for example, see the values of these variables, whether here or in the special view, and we can go step by step. Oh no, we do not need this one, sorry. So back and now into our code. For example, is this true or false? Now we see that this is true. Actually, this variable is responsible for some kind of optimization that assumes that usually you take lock from the same thread. Well, let's go further. Assert. Then we let us. This code that's what I did after I started be interested in these internals, and that code make me think that it is somehow cached in the object. That's first.
That's where it comes from.
And if we go inside, we don't see very much interesting here, but we see that it is 0, and so we are moving to the most interesting function in this respect. Now it's get next hash. Okay, and here we see, well, this function can be learned without debugger because it is quite straightforward. We have some variable, global variable, that now, let us enter the function, that now has value 5. And depending on this variable, different algorithms are used. For example, if it is 0, then we call this kind of random. And when it is 1, it is made from address of the object, I guess. The most width line is that one. If this variable is 2, then any object which class of which does not override this function returns 1. That's just for testing. And by default, this value is 5. And the commands say that it's Marcellus XOR shift scheme, which generates random number, which is afterwards well, let us skip this. See, go further, and so. And we should somewhere cache it, right? We will cache it as soon as we get from the function. Yes, sorry, I skipped this method. If we go inside, we see that we store this hash value in the object. So we want, and this guarantees us that that once it is calculated, it is the same forever. So that's basically it about the hash codes. And okay, we can release this. Now I released. I forgot to set second breakpoint. Yes, sure.
In that case, like, it's
You can talk a bit louder for everyone to hear.
I'm just low, too low. Sorry.
So it generates just some random number, and
Yes.
then it stores it.
It generates
with that associated with that object.
Exactly. It generates some random number and then stores this number in the header of the object. If we go to this mark hash, we'll see this class, and if we which is a type def, and that one describes. Sorry, I probably clicked too fast. What I did, I walked by hyperlinks to the class used, and here is an extensive command that says that hash takes first 25 bits, and actually, well, just and then this is the method that I don't see. I can find the actually. I forgot where it is. Where it is. It should be merged into header here. It's a pointer. So now, yeah. The value is it's funny. The value is actually this pointer that is just casted to pointer to an unsigned int, and then so this is in fact the pointer to the same object, and here we assign here we must assign the hash code into the object. So that's basically it about this experiment. And after I did some docs, I found how to change this these global variable that controls which algorithm is used. And I don't know whether it's lost to demo. If I don't like to type. I like to copy paste more. It should be that way. If we see, say, well, let us go to our program and let us output these values. Now I use so-called abbreviations in NetBeans, which I'm a very lazy person. So I like this stuff like that very much. So I will now see that hashes some value, and if we go to this project and to run options and to VM options, here's one that is responsible for hash code generation, and this is one that allows such weird things. And right now we'll see that this one. Sometimes, by the way, sometimes it is useful for kind of very harsh testing of your, I don't know, if you write a container or some algorithm sometime.
So for every object, it will return the same value, right?
Yes, and yeah, and even if we do cycle here, obviously these are different objects, right? Right now, if I write it that way, then normally all hashes will be different, right? And now, 1, 1, 1, 1, 1. As soon as I remove this, sure, they will be different. That's for sure.
Is there any time where it can come useful?
Frankly, for me, it was useful just to understand that I can go into the sources and understand what it does. And for me, the first example was quite useful.
No, I didn't
and with hash,
I meant about that hash code generation option too. Like whether that can come in handy in any scenario. Like
I never met such.
Okay.
Such situation.
Okay. But
So
whatever example,
it's just a funny example that makes me, what? I'd like to share. My main idea is that if you use NetBeans with both Java and C++ support, and if you open this project, you can get into these sources. You can browse it, hyperlink, study it, debug it. Although here I should mention that for such debugger, for native debugger to be launched, I need to step into the native method.
Mm-hmm.
If I just launch Java debugger and then set some breakpoints into native code, it will not be launched because the IDE has no idea why did I set this breakpoint. Probably I'll launch native afterwards. So it should be either you should try to step into the native method, or just another example is if I do that way and launch it. That's just a very simple function, just for the Java process not to exit, and then I can try attaching a debugger, and then I should select. By default, it will be Java. I can select JDB, then filter my Java. Oh, I have to. I don't know what to. No. That's. I forgot. Sorry, I forgot to tell you one more thing. To be able to do so, I do not use the Java that I downloaded from the site, from official Oracle site, but I built this Java from sources, which is quite easy. It is just configure and then make. And there are well, if anybody of you are interested, I'll send you how to do this. Oh, publish it somewhere. Because you just should configure this Java source with a special option to be able to debug, because by default it does not allow debugging. And since it does, you see that this Java is somewhere in my home directory, and then I can attach, and if I attach, then I can go there with this message from Ether and oops. For example, set a breakpoint, and as soon as I and here we are. Basically, that's it about the. Yes. Then I just encourage you to, if you, I guess the majority, I know the majority of you are Java guys. I encourage you to explore it. It's fun. Yeah, it's sometimes very useful, and it's always fun. Yeah. If you are, there is one more small piece of information. If you are interested in, then I can tell you about the possibility of about the situation when I have a Java code, and for some reason I need to use a native method of my own, and then IDE can help me with generating all the stuff, and so that I do not need to. So that I need just the implementation of this method. And also it is able, in this case, it is able to debug, to go from Java code directly into my C++ native implementation. Would you like me to demonstrate this one, or it's not very interesting?
I think we would like to see that. Right?
Okay. Okay, so let me create another Java application, and
just a bit louder, I think. Yeah.
Oh, sorry. So I created a Java application, and I'm going to add a static native, I don't know, int some method, and to invoke it here, to assign value, and again to so let's see. So as soon as I build my application, I can.
This is very cool.
I can right-click my Java class, and then go to Tools, Mixed Development. Unfortunately, it's just rather long way from menus. That's because
you can also right-click on the native. Compute the native modifier. Can you? I thought you can also do that on the native modifier.
I never tried this. Yeah, yes. I'm not sure. I never tried. I never tried it that way. Okay, so by Tools, Mixed Development, I can ask IDE to generate a project for this native code.
And that's only because you have a modifier native.
Yes. Yes.
So if there was no native in that code, this would not be enabled.
That's true.
So it's all from this, because you have these letters native in there, that all of this is enabled.
And I should also have both C++ and Java enabled. So if you know, when you are in the ergonomics mode and activate only Java, then just this functionality is not activated. So if you use ergonomics, then you need to try to enable C++ by trying to create a project. Just say create a project, it activates, then escape. That's it. Because NetBeans has an ergonomics mode that allows it to start up faster and not to load all these languages that were listed today in the memory, but do it by request. And in this mode, C++ by default is not activated until you either open C++ project or try to create project. So, okay, so I just
a complete C++ project will be created because you have that native modifier. Yeah.
That's true. So yeah, actually, Artyom has a video on this. On this. So we now see that we are in the CBP file, which already has a generated stub. And we can also, via this button, switch between CPP and H file, and we see that a header file is generated. And here I just right now 1, 2, 3, and build my project. And apart from that, if I go to it slightly modifies my Java application in terms of, it does not modify application, but in project properties, it adds -d option that allows my Java to know where to find this native library. And so if I go back, the only thing I need to do manually is load this library, because IDE does not know where to insert this code. We could do this easily if we had an idea they would like to insert it. So, and now let us try. Here is this 1, 2, 3 that I returned. And also if I invoke Java debugger, well, then I can go into
step from Java
this to step into, and now the native debugger is being launched and the process is being attached, and now we are here. Next time, within this session, next time I'm stepping into it is fast. First time is not fast because of all that stuff to be done. And now, so if you're going to try this, you should understand that it's a situation when two debuggers act together. And so when I stop in native, then Java debugger is not working. So if I switch session to Java debugger, it's just not working. As soon as I release native part, Java debugger works. So that's basically it. The very last thing I would like to mention is that well, it's like it's actually it's actually like in Java. We have not only find usages, but I can find usages of everything in the IDE, but sometimes I found usages of this field, but sometimes I need to know who uses these functions that use this field and who calls these functions which use these functions that access this field. And for that purpose, we have a call graph, which can be activated not only on methods and functions, but on fields or variables. And we see that is used in this or that. So, and these functions, and we can also expand them and investigate the situation further. And further.
Callgraph is
Yeah.
there for Java as well?
Yes, sure. In Java, there is a call graph as well. I personally usually use it that way, but sometimes for the sake of documentation, it is very convenient to say export this one as graphical file.
Yeah, it is very.
So now that's it. I'm done.
Thank you.
Thank you for your attention. Sorry for being too long voice.
Thank you. Maybe we should take a small break.